Today I'm going to walk you through a quick tutorial on how you can use Cleanlab to improve the performance of fine-tuned large language models. In this notebook, we will be using APIs provided by OpenAI to fine-tune their DaVinci model, which is a backbone to their GPT LLMs. I'll first use our original data to get a baseline accuracy, then take a look at how we can use both Cleanlab Open Source and Cleanlab Studio to improve our data and get better model performance. For our data, we will be using a version of the Stanford politeness corpus that has been adapted for fine-tuning classification. For each example, we have a prompt, and the goal is to classify it as impolite, neutral, or polite as a completion. So, for example, if the prompt was, "Why would you doubt that?" And for that matter, why wouldn't you rewrite it yourself? We want the LLM to respond with impolite. Our training set has just over 1900 examples that were annotated by a single human, thus we can expect some may be unreliable. Our training set has 408 examples and was annotated by 5 humans, so we're pretty sure we have a high quality benchmark to measure accuracy with. We won't ever touch this test set throughout the notebook to ensure fair comparison across different experiments. In the first experiment with the original training data, we see that after fine-tuning we get 63% accuracy on the test set, which is pretty lackluster considering this is a 3-class problem and we're using an extremely powerful LLM. Let's use Cleanlab to find what might be causing this. First, we will use Cleanlab Open Source to try and find some label issues. To use the find label issues function, all we need is predicted probabilities for each of the training examples. To do this, we first get embeddings for each example using the same DaVinci OpenAI model, and then use cross-validation with a logistic regression model to convert the embeddings to predicted probabilities. Then, we simply pass them and the labels to the find label issues method to get a list of indices sorted by label quality score. Here we can see some examples that Cleanlab detected as being mislabeled. Check out this one, which says, "I'll take a look at the get log entries when I have a time. Would you mind adding me as a committer?" Which is clearly a polite request, yet it is labeled as impolite. Now that we have a list of examples that might be problematic, let's use a very simple approach and just drop them all from the training set. After doing so and fine-tuning the same model, we get an accuracy of 66%, which is a 3% improvement over the baseline. With minimal effort, we were able to improve our model using less but better quality training data. 3% is great, but I think we can do better. Instead of just dropping those examples that might be problematic, let's fix them instead. To do this, let's use Cleanlab Studio, which is an enterprise data correction interface that works with many types of data, like text, tabular, image, audio, and more. Studio provides everything necessary to correct issues like label errors and outliers in your data. You start by uploading your data and defining your feature and label columns. Once you create a project, Studio uses AutoML to predict which examples might have issues, as well as provide suggestions to corrections for each. Using the interface, you can choose to keep the given label, relabel it with the Studio's suggested label, or relabel it with any of the other labels. Once you're satisfied with your data, in just a few clicks you can download your improved dataset along with all of the metadata that Studio calculated for you. After fine-tuning the same model on this much improved data, we get an accuracy of 77%, which is a 14% improvement over the baseline. It's clear now how much the mislabeled data was affecting the LLM. I also ran the same process on a few other OpenAI models, Ada and Curie, with similar outcomes. I hope this video was helpful and interesting for those working with text data. If you'd like to see how Cleanlab can help you with a variety of data-centric AI tasks, check out the links in the description below. Thanks for watching.